Hello everyone, welcome back to my channel. My name is Pranava and in today's video we are solving a room of TryHackMe called as the directory. It's a pretty simple and straightforward room of TryHackMe. It's all about packet analysis. I love packet analysis and we'll see some interesting cases here in this video. Okay, so moving to my screen here, as you can see on my screen, we have already finished this room and let me start reading through the challenge description. Directory. Do you have what it takes to crack this case? Yeah, let's see. And the description is here. A small music company was recently hit by a threat actor. The company's art directory, Larry claims to have discovered a random note on his desktop. Given that they are just starting, they did not have time to properly set up the appropriate tools for capturing the artifacts. Their IT contact only set up Wireshark, which captured the event in questions. You're tasked with finding out how this attack unfolded and what the threat actor executed on the system. Click on the download task file button on the top of this task. You will be provided with an traffic.pcap file. Once downloaded, you can begin your analysis in order to answer the questions. Okay, so I have already downloaded the questions. I can open up my terminal here. Okay, let me go to my directory where I have downloaded this file, TryHackMe directory. And you can see here that I have a traffic.pcap file. What I will do now is go back a folder, and inside the YouTube folder, I will create a folder called directory, in which I will copy paste the traffic file. Yes. Okay, so I have the traffic file here. And what we'll do is we'll open this traffic file with Wireshark. Wireshark is basically a network analysis which you can capture and analyze the network traffic which was going through your any particular interfaces, or if you're capturing the entire network, it's going to showcase the entire network flow. So I'll open this pcap file. If I can spell Wireshark, wire H-A-R-K. wait, Wireshark. Okay, I know the spelling. I'm just I don't know what happened. I just went blank. Okay. So this is Wireshark page. Now, if you're new to this Wireshark, I recommend you go through some courses or some modules or some rooms to understand about this tool and what these packets really mean and what do they showcase in any of these packet files. I would recommend you all to do that. I'm going to go straight away to the challenges, not going to be explaining about Wireshark and the packet captures and all those information. But specifically, if you are interested in Wireshark, you can just go and learn. To solve this challenge, you can follow along. Okay, so when I look at this file directly on here, the first packet that I see is that someone is asking who has 10.0.2.75, tell it to the host 10.0.2.74. So it's basically if you're trying to connect to some other system or trying to ping another system from your local network. For example, from a computer A to computer B, if you're pinging computer A from computer B is going to send a broadcast message. That's what is showcased here, a broadcast in the entire network asking who has this IP address. And then either the switch, the router, or any DHCP server which is present in the network is going to reply with, hey, this is the MAC address of this IP address. So that's what is happening in the first two messages. One is going to be a broadcast message. It's asking the host 10.0.2.74 is asking who has the IP address 10.0.2.75, and the switch or the router or any service which provides the IP address and stores the MAC addresses is telling the 10.0.2.75 is located at this MAC address. It's basically the OSI model of MAC address and IP address syncing together, all those communication. I'll not get too detailed into that. But after that, we see the host 2.75 sending multiple requests to the host 0.2.75. And there are a lot of communication which is happening back and forth with the host. The let me define some terms to this. Let's say the attacker machine and the target machine. So there are a lot of communication which is happening between the attacker machine and the target machine. In here I can see the attacker machine assuming, because of the services or the communication request that it is sending, like the synchronization request, I can assume that 10.0.2.74 is the attacker machine and 10.0.2.75 is the target machine. Here there is communication of those things. As soon as I see this, I see a number of synchronization packets coming in, and when I see reset and acknowledgement packets coming in, I can somewhat give a guess that there is some kind of scanning, such as nmap scanning, which is happening in the background. This packets what we are seeing are probably from nmap. How do I say that? Is because if you run any nmap tool, let me just showcase that here. If I run any nmap scan, for example, I'll take a stealth scan just for the purpose of showcasing. If I perform this against a target of my local machine which is present in this network, press enter, this first sends a series of synchronization requests to the target, in my case, which is 1.2, and then tries to see which ports are open. Now, the way how synchronization can occurs in nmap is the target system is going to be bombarded with a lot of synchronization packets from the attacker machine asking for, hey, are you open in this port? Hey, are you open in this port? Hey, are you open in this port? And the target system is going to reply back to the attacker system either of the two ways, that, hey, with the acknowledgement packet or synchronization and acknowledgement packet saying that, hey, this packet is open. If the port is not open, it's going to reply with, hey, this port is not open, which is a reset and acknowledgement packet. So that's what is happening here. I can see a reset and acknowledgement packet being sent forward from the target system to the attacker system. Let me just go a little tangent and just open. Let me not open a file, but let me just close this case or something like that. Can I do that? Yeah. And let me just try to capture my interface. Okay, I guess I'll have to exit this from the terminal. Let me close that and run sudo with that. Wait, let me close that. I don't need that. Let me just open Wireshark. Okay, so Wireshark is open here. I have one of my interfaces. There is some traffic in it. I'm not sure what are those. Anyway, let's just click on that. So I see a lot of messages going forward. Let me make sure and know what exactly is my IP address. My IP address is 192.168.1.98, which is my local private IP address. And my target system is 192.168.1.2, which I'll perform an nmap scan. But yeah, straight away you can see a lot of messages passing through in my network, either from my server or just a random communication that is happening in my network. Let me stop it and let me set up the same nmap command here and then run a fresh scan, continue without saving, and then run the scan. Let me get the output, and there we'll be able to see, yes, we get the output. Let me now close this. All this is just going to fill my system with all these information. Now, can you see from the source of my system, which is 192.168.1.98, I'm seeing a lot of synchronization packets being sent to different ports, probably top 1000 or top 100 ports with the synchronization packets. Now, the ones which it replied with these ports numbers as turned on, we might see a synchronization and an acknowledgement packet somewhere down. Let's go for it. We can probably even filter saying that IP dot, yeah, source. Okay, I have this here. Let's have this. And we are also seeing some of the reset packets, right? Port 80 is there. and they've sent some synchronization packets from the target system, sorry, attacker's system to the target system. Let me flip the switch from 98 to 2 and then see what communications were sent. Okay, there were only few things because I have a firewall enabled in my network, which doesn't reply to any of the such as scans and those things. My network just drops such scans, but the only ports which were communicating back to my server or back to my attacker's machine were the 443, 22, and port 80, which is basically a website which is hosted internally here. Only they are replying. That's what happens. They are printing out with synchronization and acknowledgement packet. Now, if I perform instead of a cell scan, a complete TCP connect scan. Wait, yeah. Let me go here. If I remember right, the switch should be T. Let's try. Let me also open Nmap and help. If I can spell things right today. I don't know why. Yeah. So that's the script scan, service version, sports scan techniques. Yeah, ST is for connect scan, right? That's what I want to showcase. So when I do this scan, let me clear all these filters and then start another network capture. Press enter. Here we'll see a little different kind of network communication that is happening here. That's done. So let me close it. Now let me apply the same filters which I had applied. Let's come to this. And we can see a synchronization acknowledgement packet passing through. Let's flip the switch now. Now this is 2. 98. What's wrong? Oh, the IP address here is wrong. Okay. Yes. Here, there's a lot of messages that is passing through between each other. We can see a reset and acknowledgement packets for 443. Somewhere a reset and acknowledgement, okay, to this port. From this is the port number from the attacker's system and the port number of the target system. So I wanted to showcase basically a full handshake. That's what was my motive. Yeah, this is a full handshake at port 80. A synchronization message was earlier sent somewhere from, yeah, the synchronization from 98 to 2. Okay, no, this is not the full handshake. But anyway, I guess you get an idea of what exactly are we looking at in that. Let me open that pcap file once again. Close without saving. I don't want those filters. Yes. So this is the pcap file. That's what we are having here, which is an nmap scan that is happening against the target. Now let's read through the question and analyze what exactly do we want. What ports did the threat actor initially find open? Format from lowest to the highest separated by a comma. That's good. So as I said, now when a port is enabled, the target system is going to respond to the attacker's system with a synchronization and acknowledgement packet, which confirms the presence or open of that particular port when the attacker sends a random port numbers to verify. So straight away I can see here in the port 23, sorry, the packet number 23, a synchronization acknowledgement packet that is being passed from the 55 host and replying, which is the target host to the attacker's host. Let me open here, and if I have to manually go and just search with synchronization acknowledgement, that would be a lot of headache for me, right? So I see another synchronization packet. What I will do is, here there are multiple flags there inside. These are all the breakdown of the network contents, what is being transferred here. So under the flags, I see synchronization and acknowledgement packet being passed. Let me right click on that and then say apply as a filter, which is basically applying a filter on showcasing only the ones which has synchronization and an acknowledgement set forward. So I'll say selected, and I see a lot of ports which are enabled from the target system. which is replying with a synchronization and acknowledgement. We have 445, port 80, 139, 53, 135, 446. All those ports are enabled in the target system. That's what we are seeing from here with a synchronization and acknowledgement packet. This is one of the way. You need to arrange it now manually, or else we have another smarter way which we can also do in a command line. Let me exit from this. And okay, Wireshark is running in this terminal. In that case, let me clear this. Hope I have the traffic file here. There's another tool called as TShark, which does something similar like how a Wireshark does, but on the terminal alone. You can see there is a lot of packet captures happening with TShark. With TShark, you can also have a packet file analyze. Let me open the help tab of TShark here, and we can juggle down to what exactly the commands and switches which we want for analyzing it today. The first thing is, yeah, this also does of capturing the network traffic, but since we want to analyze, we'll have to specify our packet capture file, which I guess it's somewhere here, -r as a switch, if I believe. Input file, yes, the -r. Let me parallelly build down my command that I want to enter. So I will say tshark -r, and then I'll specify my file. Then inside this, now if I open the Wireshark here, I see there are 11,000 packets which are stored in this particular file. Now if Tshark has to go through all these files and then be able to give us a filtered down version of it, it would take a lot of resources. So I want to limit down and cut it down to probably something like around, I see a lot of traffic here. Probably these all could be a repeated thing also. So probably around 4,000 packets. Let's start with that. So I will say just give a count of 4,000 packets to look after. After that, it's going to end going through the file. I hope that option is right. Count packets. So stop after n packets. So by default, it's infinite, but we want around 4,000 packets. Now, what exactly are we looking in that? I want to look at the parameters or the fields of this particular packets that we are looking at. So we use option T. If it's right here, it's basically the what contents are we looking at. So I will say -T fields, fields, and then what are we looking in that field is what we are supposed to also mention. So -E is another switch. Let me just go here. Now the field that we need to print here. In this case, the field that I want to print is nothing but a TCP source port, right? That's what I want to see. What are the fields that I want to see? The port numbers is the output that I want to get from it. So I will say TCP source port. Now here in this case, this is the port, this is the source, so hence the TCP port number of that system. And in what are the specifications of what exactly port numbers, not just random port numbers, but specific port numbers. For that, we use -y, which is defined for, let me just go up. Let me give the exact information. Packets displayed filters in Wireshark display filters. Okay, basically, I'm applying a filter now here. Or what exactly do I want to see? In my case, I want to see something which has a synchronization as well as an acknowledgement packet in it. So I'll say tcp.flags.sync, which is synchronization, is equal to 1, and tcp.flags.synchronization, sorry, acknowledgement is equal to 1. Let's bring this command here in the top and remove that semicolon and enter. And I get a list of ports which was seen directly in an order. Let me filter or sort this, sort, and that's going to sort it in descending order, I guess. No, it has just made everything even. Let me sort that with even like ascending order with the port numbers. So that has sorted us with the port numbers. Let's also make it unique. There are a lot of repetitions. So unique, UNIQ. And yes, we see the port numbers which are enabled by the target system of these ports which the attacker initially found. So that becomes our first question's answer. What ports did the threat actor initially find open? Now let's go to the second question. The threat actor found 4 valid usernames, but only one username allowed the attacker to achieve a foothold on the server. What was the username? Format, domain, top level domain slash username. Okay, so now basically I'm just jumping the gun round here, but if you're specifically analyzing this packet captures that we are seeing here, we will also notice by some of these ports that there is an authentication happening because the port numbers 3268 and 3269 are a part of Kerberos authentication ports, right? They use these protocols like Kerberos use these ports numbers for authenticating the client's computer into the system. Now that comes with a little bit of experience about working with Kerberos and Active Directory environment, but that's what I would get a sense here. But even then, if I just scroll through the packet capture, I see a lot of, let me remove this filter. Yeah, and if I scroll down, initially I see a lot of Nmap scans happening. Where's my cursor? Okay, I'm not able to see that. But anyway, while scrolling down, let me scroll down a lot further down. This is all the Nmap scan. Probably they're looking for all the ports which is enabled in the target system. Let's go down, still down. I'm not able to see my that scroll bar anyway. That would have been easier for me. Okay, suddenly here I see after the TCP protocols being sent, the Nmap scans being sent. Let me just go down. Here, probably they're looking forward for some other traffics, or the system is just replying to their information. I don't get a clear picture, but anyway, something else is happening here. We see a lot of information about those. Let's go further down. It would have been so good if I could get my cursor working for some reason. Yeah, now there is something else happening. Another broadcast message which I see from who has, again, the attacker is probably trying to perform another scan. Okay, down here I see a lot of more. This is probably push and acknowledgement packets. Probably another Nmap scan with connect scans and those protocols. Let's scroll further down. And I see a lot of HTTP protocols being used now. So far, it was all TCP, which was happening between the networks itself, between the computers just communicating themselves. But suddenly down here, we see an ICMP. What is this? Unreachable. Okay. And then we see a lot of HTTP responses going around, which is good. Okay. But again, scrolling down, TCP, we see another responses going from the target and the attacker's machine. Probably they're trying to do something there. Let's go down, further down. Okay, I guess some other scan is happening here. Let's still go down. And okay, HTTP is done. Somewhere down here, we start to see some acknowledgement packets. I guess this is still of HTTP. Let's go further down. Further down. I wish I had the scroll bar. Okay. Suddenly here we see AS request, which is basically Kerberos protocols coming in, which is a part of something which authentication process is happening. So I see the attacker is trying to authenticate into the target system using Kerberos. There are a lot of attempts which is happening. And if you try to break down this Kerberos, and if I open this body out, let's open the CNAME. We can see that they're trying to predict the username JDO and the directory name or the domain name of the system. We see directories happening here and a CNAME there, but that was not successful. If it was successful, we would get a different protocol seeing there. I'll come back to what it is, but you can see that a CNAME string, which is basically the username, and then the domain is being passed there. We see a lot of errors, probably the errors of the attacker is trying to brute force. We see a lot of errors, and okay, that still continues to happen. And somewhere around this packet, if I am specifically right, I see REP, which is coming up, which is basically a protocol which tells that the protocol has been successfully done, or the user has been successfully authenticated. Right there, if I open up the information and see what exactly were the data which was being passed, let me open the CNAME. I see a username called larry.do and a domain name directory.thm being passed there. That answers the second question. Now, how did I know it's Kerberos? One thing, by the port numbers that I saw initially that was being used for this, which is the 38. I actually forgot. Yeah, 3268 and 3269 are basically used for authentication of Kerberos, and any other method which would actually let us to look for the passwords would be one of these case itself. So again, you'll have to analyze all these packets by yourself, but just the purpose of showcasing, that's where I found the username and the domain of this system. So that answers our second question. Now, coming to the third question, the threat actor captured a hash from the user in the second question. What are the last 30 characters of the hash? Now, this is an interesting thing. If you see this, these are the hex characters. If you look at the encryption part of this message, we see a cipher which is being passed here. This basically is the cipher text or the hash. It's basically not the hash, but it's something which the Kerberos just generates as a process of authenticating. I'm actually forgetting the exact term of it, but it's not the hash of it. I'm very clear with that. It's not the hash. It's something else. One of the person in the Discord had pointed out in their blogs. So yeah, I'll just link it down or I'll just put it on the screen here. But yes, that's not the hash. What we can do is let's copy this. I'll say copy as hexa dump and then open some text editor here. Then paste all these things there. What we get is the hash of it. Now the other better way is to open Sublime Text, put it into this screen, paste it here. I'll select everything, Control Shift L to put a cursor in all the end, bring it to the beginning, remove all these white spaces and press backspace. That's good. Then replace everything with Control H, find space and replace with nothing. So replace all. That's good. Now I have this text. Let me replace everything with that and select the last 30 characters. I can see it here down. Last 20, 26, 27, 28, 29, 30. Yep. So these are the 30 characters I can see down here in the down in the window. This is the last part of the cipher text that we get. So last 30 characters of the hash from the question 2. That's exactly not the hash. That is another method which I found while I was trying to solve for the further challenges. Is I wanted to Google decrypt uh, decrypt, yeah, WinRM. I'm forgetting that term. 1 second, let me just go through my notes. That's why it's very important to make notes during this. A GitHub repository for this question. Yes. So how to extract Kerberos hash from a pcap file. This was okay. Let me It went to that window for some reason. Okay, so this is the exact Google search which I made and went through all these blocks. The one GitHub repository which I loved was this particular repository, which would help us into getting the contents of basically extracting the hash from it. Now that's the exact way I did by copying from this pcap file with the cipher, but this repository was really good for it. Let me copy this GitHub page and showcase this method too. Let's say, let's clone it here itself, git clone, and then the URL. Have they specified any requirements? Not so far. Yeah, but the way how we are supposed to use is we need to supply with the pcap file. And then what exactly are we looking at? Now we need to look at AS rep, which is basically an authentication. Once the authentication is done, we get this protocol being sent. So we want those in that response sort of it. So let me move that directory and ls here. Okay, I see curb roast pass there. So Python 3, then curb roast. Let me pass the pcap file traffic, and then I want this one. So let me just paste it there and then press enter. And yeah, by here you can just select the last 30 characters or any n number of characters of the system to be able to enter it. Basically, that's the cipher, not exactly the hash of the password or the authentication that was done. The next question is, what's the user's password? Now, for that, what I did was copy this, because this is anyway the authentication cipher which is being passed, which contains the password of the user. So copy that and then say, we go one directory back, and I will name this as nano directory dot hash, and then paste that in here, xyz enter, and then say hash cat directory dot hash, and then I will use my rocky.txt file. So tools pausing list rocky.txt and run this. So I've already run the scan. Let me say show, and that shows the password here. We get to know the password of this user who had authenticated. So the user Larry had this password. That's what is being asked here. Now the second, the last, or I don't know what's the number, 1, 2, 3, 4, fifth question is, what were the second and third commands that the threat actor executed on the system? So format 1 and 2. So when this question arises, what were the second and third commands which was done, which means that the attacker, after gaining this access, they were also able to get some remote code or reverse shell from the system, or a PowerShell connection back to them. So let's go forward in the pcap file and search for such packets being transferred. So I'll scroll down, and right away I get WSMan, which is basically Winsman, is a protocol which is used for getting a PowerShell to back to the system, right? That's what is being used here. And we see some more protocols being passed here and there between. A log off request was done, and those communications are happening here. But if I try to just follow this TCP stream and then look, okay, there is no content here. Let's remove this. Basically, it was trying to get those connections. Let's okay, postman here. This one is basically a communication happening from the source to the destination. You follow this HTTP stream, we get more information. So, but that information is basically encrypted. Now we need to try to crack this encryption method. There are multiple ways to crack it. We can search for that also in Google. How to extract. Again, I'm forgetting the Google search for some reason today. Let me open up my notes and just refer to it. Uh, Where is that? Okay, wait, let me just Google that itself. It was how to decrypt WinRM in PCAP files. PCAP files. Okay, let's just Google that. Yeah, decrypt WinRM. Yes, this was the repository which I got, in which they showcased about how do you decrypt a WinRM communication which is happening back and forward through a PCAP file. But for some reason, this code did not exactly work. I cloned this code and tried, but there was some errors which was happening. But luckily, they said that it is modified from this. So what I did was I just copied this, went to the raw, and copied all the contents. Wait, let me copy this file first. File name. I open up my terminal here and then say nano decrypt the winrm underscore decrypt.py. Then come back here, copy this code, paste it back there, XY, enter. So now before running that, they have given some pre-requirements which you need to be running, pip3 requirements.txt. What I will do is come here and just copy these contents and build my own requirements.txt file and then paste that in, XY, enter. Then say sudo pip 3 -r requirements.txt, press enter. What is it? pip3 install. Okay. This error. Yeah, you can create a virtual environment and still run this, but let me do what it requires. It just downloads all these things. So yeah, oof, that's some error. Whatever. But yeah, running this tool doesn't actually work. So I took this code, and the usage of that code is basically Python 3. Then where is that? winrm.decrypt.py. You need to specify some arguments to it. So the first thing that I want to present is basically the password for it to, basically these communications are encrypted. So we need to provide it with the password of this user. So password 1 and the pcap file, right? We need to specify the traffic.pcap file. Let me open my notes to look at the exact commands so that I am not wrong. Yes, it's the same thing. So now running this, okay, just try to give, let me print this on my, on some files, okay? We'll put all the output of this to say output.txt. That will be a better thing. Let me put it there. Basically, it's going to look for any WinRM communication happening in this PCAP file. It's going to try to decrypt it individually. This is you can do it in another way, which is to come here, edit preferences, and then protocols. There's somewhere option for this also. If I remember, it's we need to scroll down somewhere. Somewhere it's there. Yes, NTLM PBS. So you can enter the password here and then individually also decrypt the communication that's happening. But I felt this is much faster. So if I try to print out the head of this output.txt, we don't get much information, but then tail of this output.txt, or even if I just carry it out, I'll just kill it immediately. I get this entire bunch of code here, which looks like a base 64 code, but then I did not know what exactly to do, and I did not understand anything of this, right? So, and then I actually followed a blog post of one of the members of TryHackMe, and then asked for some help there, and they told me a certain steps that was happening here. Let me give you this context here. So what exactly is happening is that our attacker is trying to execute some commands in that PowerShell script or the PowerShell session using WinRM. So those communications are encrypted using their passwords. So What we did here was to use this Python file, this Python code, and then get the contents of what was being passed between the target host and the system, decrypt it using that password, and save it into an output text file. Now, inside that text file, there is another layer of encryption which was happening by the tool itself, assuming that they were also running some Python shell. That's what they specified to me. If I open this pcap file, I would get it. Let me just close this communication here. They, yes, it's a user agent is a Python ps rp client, so that was encoding this communication between the target and the attacker's machine using base64 encryption. Now you can copy this entire content into your clipboard, open up cyberchef or any other tool, and then try to decode it. But they shared me with a better command, which was this. I'll just copy paste it here and explain you what that command does. So it's basically grepping out from a file that we will be specifying later, and then it's going to look for some arguments within that quotes range. These arguments, again, you'll have to look into the file to be able to understand it. So it is going to look into those parameters, and then cut out any other arguments between those open brackets and close brackets of this file, and then it's going to save it as encoded arguments.txt. It's going to only select those base64 encryption and not any other contents which is present inside that file. Let's rename this because I don't have that file name. Let me change it to, what was that, output.txt? Yes. So it's in the output.txt. It's going to paste out all the contents there. So if I print the head of encoded arguments.txt, it's just containing the base64 arguments. So this is not the same of head.output.txt. In that, it contained all the other information also. So we don't need that. We need just the base64 code here. Now to decode this, there's another line, there's another code. That's what I'll just copy here and then explain it. Let me clear my screen and paste it here. So it says, while read line, it's basically a bash script which is written. It's going to read line, and it's going to read line from the encoded.argument.text. It's going to read every line and then decode it using the base64 function present in the machine, and then paste it into arguments.txt file. That's what is happening. Till it finishes till the last line, it's going to decode every content which is present inside that line. So let me press enter. That would have generated arguments.txt file, and printing arguments.txt file, we get a lot of information. Now again, since the Python tool is converting every communication of commands which is being entered in the system, it is passing through their own formatting. Now to remove these things, there was another code which was shared, which is this one. Let me copy that and then paste it here. So what this command does is that it's going to again remove all those other regular expressions other than what exactly where the commands or things were entered, and then it's going to print it in a very clean format. Again, all credit goes to the blog post. Let me even open their blog post if that's possible. I hope it's this. Yes, this one. Let me open it here. All credit goes to the user who has written this blog. Fantastic blog. Lots of credit goes to them for me solving this room at the last. Yeah, shout out to this writer. I forgot your name. Sorry. Actually, a very good friend of me from the Discord, friend of mine in Discord. But I'm sorry, I forgot your name. Yeah. So by pressing enter, we see all the commands which was entered. In there, we get the second command and the third command, which was entered by the attacker in the target system. That's what was our second question, or the fifth question, if I'm right. Yes, that was the thing. And last, there was a text file which was echoed into the system. It said node.txt, and the content was the flag, which is the answer to our last question. So yeah, this is what was the machine directories. I loved it, and it was hard. Basically, the last part of it, because I was not exposed or did not basically understand the further steps with the WinRM and the PowerShell, which was there. But rest of the contents was actually kind of easy. Again, you need to know about Wireshark and information about it. So yeah, hope you did love this video. If you did, hit on that like button, hit on that subscribe button if you're new to this channel, and do all those YouTube algorithm of liking, sharing, subscribing, commenting, all those things which will just let me be notified here or there somewhere in YouTube. Let the algorithm just pick me up some at random, recommend it to people. Let me scale up. Okay. Anyway, I hope you did enjoy this video and learn something new out of it. So if that's there, then hit on that like button, and do also let me know in the comments. I do read your comments and reply to them. Also, if you have not joined the Discord server, I highly recommend join not just my Discord server, also TryHackMe's Discord server, but mainly my Discord server, where we are building a huge community of professionals and cybersecurity enthusiasts like you watching this video who are interested anything and everything under the space of cybersecurity. We love to have you. We would be very welcome to have you. Let's get some engagement done also in Discord. So hope you will. The links are there in the description. Hope you will join, and we'll meet there soon. Okay then. So till then, till the next time, stay happy, stay smiling, stay hacking safe. Again, remember, hack safely in an ethical manner. Okay then. Bye bye. Thank you. Thank you for your time. Bye bye.